That's why we have P6 kind of extended for really 4 days, because we're looking at how do you factor every single type of polynomial. And we're even going to look at how do you factor a non-polynomial. Today we're going to continue working with trinomials. How many terms does a trinomial have? Josh?
3.
Yes, good. 3 terms. Now, if you remember from yesterday, with any 3-term polynomial, you try to use the trial and error method to factor. So that's what we're going to be using today. But we're going to use it with multiple variables inside. So looking at number 1, what is the first step for any polynomial with factoring? First step, Caitlin? Yes, awesome, Caitlin. Greatest common factor. So looking at all these 3 terms, is there a GCF?
Yes.
Yep. What could we take out?
2.
2?
2a squared.
2a squared. Awesome. So I take that out, and that would leave me with a 12a squared plus 5ab minus a 2b squared. Now we do use the trial and error method, so we're going to continue with what we looked at yesterday. I'm going to write my 2 parentheses because I have 3 terms there. I know I'm going to kind of unfoil. Keep my GCF on the outside. And the first step is determine your signs. So the last term is negative. Therefore, do we have the same signs or different signs? Different. Good. Therefore, different signs. So I'm going to use a pencil because I'm not sure where they will be, but I'm going to put a plus and a minus inside. Now we undo the FOIL process. So we're going to undo F. First times first. What times what would give me a 12a squared? 3a and 4a, that would work. Maybe a 6a and 2a, or maybe a 12a and a 1a. But you guys said 3a and 4a because we most often choose the ones that are closest together. Okay, so let's put those in. 3a, 4a. Now, looking at 2b squared, what multiplies to be a 2b squared? 2b and b. Now, before I place them inside of the parentheses, let me stop you for a second. Would I ever place the 2b in with the 4a?
No.
No. How do we know I would not do that?
Because this is the greatest common factor.
Yes, because we would have a greatest common factor, and we already took that out. So there's no way I'm putting that 2b there. I'll try to put it here, and I'll try to put it here. Now, the most important step is check. Does this refoil out? If not, you've got to relook at some numbers. So first times first, 3a times b would be negative 3ab. 2b times 4a would be 8ab. That adds up to be 5ab. Is that my middle term? Yep, so I didn't have to do any switching. I can go ahead and bold in that plus, bold in that minus, and here would be my factor down. Okay, I want you to turn to your partner and try number 2 together. Try number 2.
Great.
Okay, bring it up to the front. Raise your hand if you and your partner got it. Miracle.
3 and 9 minus 2.
Awesome.
This is in parentheses.
Good.
Parentheses 3 and 9 minus 2.
Awesome. So the same thing. So another way you could write that is 3mn minus 2 squared. Both of these would be acceptable, just the second one is condensed a little bit shorter and nicer. Nice job, Miracle and Caitlin. Are there any questions about that before I move on? Now give me a thumb about how you feel in factoring trinomials so far. Thumb up, side, or down? Yes, decent. Okay, all right, let's move on then. You can apply this trial and error method to trinomials with a higher degree than 2. Right now we've only been dealing with a square, but let's see if you could work with something to the 4th power. In order to understand that, we're going to take you back to what you know. So if you have something like x squared minus 2x minus 3, let's just think about how we would factor that down. The last sign is negative, so both of our symbols would be, what, different or the same? Different, so I would have a plus and a minus. What times what would be x squared? X times x. What times what would give you 3? 1 and 3. And we would want to put the 3 in with the negative sign and the 1 in with the positive, so that when we check this, we get a negative 3x plus a 1x, which will give you the negative 2x. Now that's not new. That's a review of what you've been doing. But what I want you to see is the box is what you put here and here. Now if we take this and move it to a little bit higher of a power, if instead I call this a squared squared, and in the box over here I put in an a squared as well, there's still 3 terms. Let's see if the trial and error method would still work out in the same way. So go ahead and write your 2 parentheses. The signs again would be different because that last term is negative, so we're going to have a plus and a minus. Now let's think of what would go in place of the x's. If I have a squared squared, what's going to undo the f in FOIL? What am I going to put in the first 2 places? A squared and a squared, right. Because a squared times a squared would give me a to the 4th. And then the other numbers would stay the same. I'd have the plus 1 and the minus 3. And the beauty of this is if I check it, I get negative 3a squared plus 1a squared, which is still a negative 2a squared. So this will work with a power other than 2. Specifically, it will work with a power of 4. There's a better mathematical process we use rather than using these little boxes, and we call it U substitution. So let's see how we can take that exact same problem and make it easier just by replacing the a squared with a u. So if I take this problem, which is actually the exact same thing, I've just simplified a squared squared, I would have a to the 4th minus 2a squared minus 3. Now if I want to make this into a quadratic, meaning only having a squared term, then I can instead write it like I have up top, a squared squared minus 2 times parentheses a squared minus 3. But now if I let a variable, and we usually use u, I'm not sure why, but we do, if we let u replace a squared, then we can go ahead and rewrite it as u squared minus 2u minus 3. And now it would factor in the exact same way that we saw yesterday. It would just factor down into u plus 1, u minus 3, and the only thing you'd have to do at the end is replace the u's with an a squared. A squared plus 1, a squared minus 3. Now, some people don't like u substitution, but when you get to the examples on the back, you will especially see why u substitution is helpful. So let's start with example A. Let's use u substitution just because it will help us on the reverse side. So looking at letter A, what would I want to let u replace? Mark?
A squared.
A squared, exactly. Because if I think of this as a squared squared minus 2 times a squared, oops, minus 48, if I let u replace a squared, that would give me u squared minus 2u minus 48. I factor this down. Are my signs different or the same?
Different.
Different because the last term's negative. So I'm going to write in a plus and a minus. What times what would give me u squared?
U.
U and u? What times what would give me 48?
6 and
6 and 8, you could use something like 12 and 4 or so on and so forth, but you guys already found the factors that work. If I use 6 and 8, if I make the 8 negative and the 6 positive, what happens when you add a negative 8u plus a 6u? Negative 2u, that's what we want. But if you've used u substitution, what is the last and final step you have to be aware of? What do you have to do at the end? Replace it. Put a squared back in. So we have a squared plus 6 times quantity a squared minus 8. And there would be our answer. Okay, I'm going to walk around, see how you're doing with this. Try letter B. Try letter B. Yeah. Well, I'll post it. Did you have homework tonight? P6 assignment tonight. All right, good. I'm seeing good things. You should have m squared plus 2 times quantity m squared minus 5. Any questions? Okay, let's try 2 of the harder examples on the back, and then we will have our tests back. So flipping it over, there is a typo on letter C. So let's replace this typo. This should be seen as 3a minus b quantity squared minus 6 times quantity 3a minus b plus 9. So this is a typo. Just go ahead and cross that off. And we'll call this letter C. Okay, continuing with that idea of u substitution, what would we want u to replace in this case? Nick? Awesome. So let's let u replace that. Let u equal 3a minus b. And then that gives us u squared minus 6u plus 9. And now we use the trial and error method. So the last term is positive. Does that mean our signs are going to be the same or different? Same. Are they going to both be negative or both be positive? Negative. How do you know? Good, because of the middle term. So we put in our minus and minus. Undo the FOIL process. So what times what would give me u squared? U times u. You guys already know that. Good. U and u. What times what would give me 9?
3.
3 and 3. So we put that in. Check it. Is negative 3u plus negative 3u negative 6u? Yep. But do we leave it like this?
No.
No. What do you have to do?
Put it back in.
You've got to bring that back in. So I've got to take what I had for u and replace it back in. So I do that, and that gives me 3a minus b minus 3 times quantity 3a minus b minus 3. What's another way I could write this? Josh?
3a minus b minus 3 squared.
Excellent. Okay, last one, letter D. Go ahead and try this one with your partner. Try letter D with your partner.
3a